Hello everyone, welcome to lesson 6-3, Solve Equations with Rational Coefficients. This lesson is found on page 457. Now remember, a coefficient is the number next to the variable. And when we talk about rational numbers, we're talking about decimal fractions as well as positive, negative numbers and so on. Social networks. 3/4. So when we say 3/4, it's going to look like this. 3/4. 3 out of 4. Okay, so 3/4 of the students in Aliyah's class belong to a social network. There are 15 students in her class that belong to a social network. So we said it two different ways. We said 3/4 of the students, or simply 15 students. So 3/4 is 15. Okay, we understand that so far? We just said it two different ways. We said it as a fraction, as a rational number, and as a whole number. Create a diagram and shade 3/4 or decimal 75% is 3/4 of it. So if we were to take, this is the entire amount of students in the classroom, right? And we know that if this is the entire amount, we need 3 out of 4. So we cut it into 4 parts. And now we're going to shade in 3 parts of it. 1, 2, 3. Right? Because 3/4. And that we know is 15. Okay? 3/4 is 15. What would be, this is where you want to start thinking, well, what's the value of 1? If 3 of them are 15, 1, 2, 3, what's the value of 1? Well, what number can you multiply 3 times so that you get 15? 5, right? So if this is 5, this would be 10 right here, and this would be 15. What's the value of this one? If 1 is worth 5. So what's the entire number of students in the class? I think you figured it out already, right? So okay, so based on that information, let's circle the equation that can be used to find C, the number of students in Aliyah's class. C is the total number of students. Okay, so let's see, 15 times the whole number is 3/4. That makes 0 sense to me. 3/4 or 75% times C is 15. Okay, that makes a little bit more sense. Because if you multiply 3/4, right? 3/4, which is this number there, that coefficient, times the value, you're going to get 3/4 of that. Right? You're going to get 3/4 of that number. So let's say this number were 20, which I'm sure you've already figured out. Well, I'm asking you what 3/4 of 20 is. 3/4 times 20 will give you 3/4 of 20, which is 15. Okay? This one makes absolutely no sense either. 4 times the value of the class is 15. No, 4 times the value of the class would be 80, right? So that makes no sense. So go ahead and circle this one. And please add the additional equation I wrote there with the fraction. 3/4 equals 15. 3/4 of the class equals 15. Okay, based on what you know about solving equations, explain how you could solve the equation you circled in exercise 2. So if we were going to solve this equation, we need to isolate the variable, right? So you could bring this 3/4 to the other side. Over here it's being multiplied, that means it has to be divided on this side, right? That could be one way to do it. If you were to divide it on this side, you would get 20. Or you could also divide it out from both sides. You have to do the opposite of what's being done over here. It's being multiplied, so you must divide it out. And if you divide it out on this side of the equation, you must divide it out on this side of the equation. You could simply divide each side of the equation by 3/4. So if I divide it out of this side, this 3/4 is gone. And if I divide it from this side, I will get 3/4 of 15. Sorry, not 3/4 of 15. I will get what? The quotient of 15 divided by 3/4, which is 20. Okay, how many students are in Aliyah's class? As you already know, 20 students. Okay, boys and girls, let's do the first little key answer right there. Thank you. So in the first one we had the coefficient was a decimal or a fraction, 3/4, right? So if the coefficient is a decimal, divide each side by the coefficient, right? So you would divide both sides to get the coefficient out. Here's an example, example 1. Okay, we have decimal 25n is 16. So we're multiplying a number times a quarter, remember, and it's 16. So 16 is a quarter of a number. You understand that? A quarter of a number is 16. Okay, so this is essentially times 4, right? Times 4 is because it's a quarter of a number. and 16 times 4 is 64. What they do here is they divide out the coefficient. So divide this side by decimal 25, which you would divide this side by decimal 25, and when you do so, you're asking how many quarters, how many decimal 25 you have in 16. Well, for every one you have 4. So essentially you're multiplying this by 4. Okay, and when you do so, you get n equals 64. Notice that it was divided out on this side, and it was divided out on this side. So let's practice that. Remember that we're going to divide out all of these coefficients. Divided here by decimal 8, divided on this side by negative 0.28. Notice how it's a rational number, and divided out on this side by negative decimal 47. Sorry, that's negative 4 decimal 7. And whatever you do to one side of the equation, you must do it to the other side of the equation. This would be a good time to pause the video and try these on your own. Okay, please pause now. Okay, so we have m times decimal 8 equals 6.4. Okay, let's divide out the coefficient. As we know, this has to be divided out, and this side will be divided out as well. I'm sure a lot of you can already see the answer because 8 times 8 is 64, right? So if you multiply decimal 8 times 8, you will get 6 decimal 4. Okay, let's try that. Okay, right here. So if we zoom it out, if we were to cancel it out, these two cancel each other out, and all I'm left is with m. And 6 decimal 4 divided by decimal 8 will give you simply 8. So m equals 8. Let's try this one. Dividing out the 2.8, the negative 2.8. Don't forget it's negative, so it must be negative on this side as well. Okay? So these two cancel each other out, and I'm left with p. Okay, or they don't cancel each other out. It's just it becomes 1. Negative 2.8 divided by negative 2.8 is 1, but we don't write the 1 in front of the variable. We know that there's a 1 there. There's 1p, right? And when I divide this positive by a negative, I know my answer will be negative because the symbols are different. When the symbols are different, it's always negative. And I'm going to get 1.5. Now, if you're doing this with a calculator, that's fine. Just remember to follow the rules with dividing and multiplying negative, different signs, positive and negatives. If you're not doing it with a calculator, make sure that you remember how to divide decimals. Remember that if you're dividing this by this, you must move this over once. And if you move this over by 1 decimal, you must move this over by 1 decimal as well. Okay? Okay, and let's try C. Let's divide it out. The coefficient on both sides. Remember that it stays negative. And now these two will divide each other out. And now I have K equals 2.3. So negative divided by negative, same signs is going to give you positive. Anytime they're the same signs, it's positive, so K equals 2.3. Okay, now let's implement this skill into a word problem, a real world problem. Jaya's coach agreed to buy ice cream for all of the team members. Ice cream cones cost $2.40 each. Now we don't know how many we're going to buy because we don't know how many members there are on the team. So we're going to write and solve an equation to find how many cones the coach can buy with $30. So look at the expression over here and try to make sense of it. We know that each cone is $2.40. Do we know how many we're going to buy? No. We're trying to figure out how many we can buy, right? So at $2.40 times a number that we don't know, times a number, it equals 30. How many can we buy? Well, let's see. How many of these are here? And that's why we're going to divide 2.4. 30 divided by 2.4. You see, when we have 2n times 2.4 times n equals 30, we want to divide out the 2.4 so that we are left with only the n. But if we do it on this side, we must do it on the other side. So it's 30 divided by 2.4, and there you go, 12.5. So the number of cones we can buy are 12.5. Can you really just buy half a cone? No. So really what you can buy is just 12 cones. Since the number of ice cream cones must be a whole number, there is enough money to buy 12 ice cream cones. Hopefully there's only 12 players on the team, otherwise someone's not getting ice cream. Let's look at the word problem here together. Suppose the ice cream cones cost $2.80 each. How many ice cream cones could the coach buy with $42? Same concept. We have $2.80 written without the units. If you were going to write it in the form of money, remember to include the hundredth cent and the dollar sign. But we're not. We're writing an equation. It's 2.8, so times the number of people times a number that we don't know is 42. And now you know we must isolate the variable, so we have to divide out the coefficient, and whatever you do to one side you must do to the other side. And now we have n equals exactly 15. And your therefore statement is the coach could buy 15 cones. Remember, the therefore statement is to answer the question, how many ice cream cones could the coach buy? The coach could buy 15 cones. Okay, here's a key concept. Recall that two numbers with a product of 1 are called multiplicative inverse. Let me just draw that out for you. Let's say you have 3/4, right? 3/4. And if we were to multiply 3/4 times 4/3, 4 over 3, right? This is the multiplicative inverse. We flipped the fraction for simpler terms. Okay, we flipped it. That's called the multiplicative inverse or the reciprocal. Remember, we always say find the reciprocal? Well, that's how we find the reciprocal. We just simply invert the fraction. And if we were to multiply this, we would get 12 over 12, which is 1. And that's why they say it's the product of 1, right? If the coefficient is in a multiplication equation is a fraction, multiply each side by the reciprocal of the coefficient. So take note of this, boys and girls. If it is a fraction, if it's a fraction, multiply each side by the reciprocal of the coefficient. So if it's a fraction, we must multiply each side by the reciprocal. So this side of the equation we get multiplied by this and also the other side. And here we have it. We have 3/4 of x is 12/20. 3/4 of x is 12/20. That's what they're telling us. Okay, so 3/4 of x, we have to see if we can multiply this out so that it equals 1. And when we do, we multiply by its reciprocal so that it's 1. And remember, we don't have to write a 1 in front of the x, right? Because 4 times 3 is 12 and 3 times 4 is 12. 12 over 12 is 1, but we don't write the 1 in front of the variable. If we multiply this side by 4 over 3, we must multiply the other side of the equation by 4 over 3. And when we do so, remember, you can cross-reference here. You have 1 and you have 5 here. You have 1 and you have 4 here, right? 1, 3, and 4 of them there. And then you have 1, 4 here and 5 of them here. And you see how that was crossed out. Okay, and then when you simplify, you have x equals 4/5. And if you replace it back in with a variable, you could say 3/4 of x. Remember, this was s, but 3/4 of 4/5 equals 12 over 20. And that's true. 3 times 4 is 12, and 4 times 5 is 20. So yeah, the statement is true. And you can simplify this to 6 over 10, or 3/5. And there you go. This concept is repeated in example 4, except now we're working with a negative. Okay, negative. Remember to follow the rules of multiplying negatives and positives. Please follow this carefully, and if you have any questions, ask me in class. Okay, now we can try it. Please pause the video now and try these 3 on your own. Okay, I'm going to multiply each side with this multiplicative inverse, and I know this is going to equals 2 over 2, which is 1, so I can simply just write my x, and 1x equals, this is going to give me 16, right? Because 2 times 8 is, 8 times 2 is 16 over 1. Okay, again, I'm going to multiply both sides by 3/4, negative 3/4, invert it, and now remember, we keep the negative. Negative times negative is going to be positive, so this is all going to equal out to a positive 1, so it's just my x equals, and 9 times 4 is 36, and it's negative 36, and over 3, right? Over 3, and when I simplify that, I have x equals negative 12. And there you go. Okay, and I've jumped ahead already and wrote in the inverse of the fraction that we're being multiplied here. Remember, they're both negative, so this is going to equal a positive. Those cancel each other out, and we're left with our x. Over here we can simplify too. I see that we have 1 there, and 8 here, and 64 here, so I know that I can simplify that to, there's 8 8s there, and 1 there, and there's 1 7 there, and 3 over here. Okay, so that's going to equal positive because it's negative times a negative, and it's going to be 3 8s. Please take a look at example 5 carefully and see how the multiplicative inverse is implemented. Okay, we'll complete the guided practice in class together, and please complete the entire independent practice from top to bottom, including